student. Welcome to my YouTube channel Mathematics Corner. I am Mukul Sarma, subject teacher. Today I shall discuss about principal argument and some solution of exercise number, this is 5.2, which is related to modulus and argument and some polar form. At first, principal argument. What is the principal argument? Let z is equal to a plus ib be a complex number, and let theta be its argument. I have discussed last class. And then the polar form of z is equal to a plus ib is z is equal to r within the bracket cos theta plus I sin theta. If theta lies between minus pi by, as pi is in the closed interval, it is open. That is, if minus pi less than theta less than equal pi, then theta is called principal argument. Ami yate argument konanko sabo lagibo. Etu minus pi aru pi bhitor jodi thake tetihale etu ami kom mukhya konanko. Aru hei value tu generally ami lobo lage. It is called principal argument বুলি ক'লে আমি মূলত সেই ভ্যালুটোৱে ল'ব লাগে, principal argument to ল'ব লাগে. But the exercise number 5.2, it is given that this exercise number 5.2, find the modulus and argument. Find the modulus and argument of z is equal to minus 1 minus I root 3. At first we have to check whether it is a plus ib form or not. If a plus ib form আছে নে নাই এটো প্ৰথমতে আমি চাব লাগিব। যদি আছে তেতিয়াহলে আমি a আৰু b লিখিলে হল। কোতে ইয়াত a plus ib form আছে, it is in the a plus ib form, therefore a is equal to real part, this is, and b is equal to imaginary part minus root 3. Now modulus of z is equal to a square plus b square root over a means minus 1 square. This is putting the value of a and b. 1 plus 3, what is it, 4. Next for the argument, that is what is the argument of z? We have seen that here a is negative and b is negative, so it lies in the third quadrant. In the third quadrant, ARGJ, I have discussed last class, minus pi plus tan inverse b by a or pi plus tan inverse b by a. That is minus pi plus tan inverse b means here minus root 3 minus 1. Here sham minus pi tan inverse root 3, that is root 3. It is also root 3. Minus pi plus what? Root 3 means, what is the root 3? This is 60 degree. 60 degree in radian, it is pi by 3. Therefore, tan inverse, in place of root 3, we write 10 pi by 3. Here also 10 inverse pi by 3. There is minus pi plus pi by 3, or this is pi plus pi by 3. This is minus 3 pi by plus pi, minus 3 pi plus pi by 3. It is 3 pi plus pi. That is minus 2 pi by 3, or here 4 pi by 3. But here we have seen that here minus 2 pi by 3 is in between minus within this interval minus pi plus pi, but it is not in this interval. So principal argument we take this is we take this as principal argument or argument. We cannot take this is not principal argument here. Therefore, so principal argument is minus 2 pi by 3, and so j modulus of z equal to 2, and we can write also it argument. Here argument means principal argument. That is 2 pi by 3. That is the problem number 1. Now the problem number that is 2, that is this is also it's an Exercise number 5.2, z is equal to minus root 3 plus I. Here it is also a plus I form it is. Therefore a is equal to real part minus root 3, b is equal to imaginary part 1. Therefore modulus of z, this is after calculation. Argument of z. What is the argument of z? That is the argument of z. Argument of z, since a is negative and b is positive, so negative positive, therefore it is in the second quadrant. Therefore in the second quadrant ARG is equal to pi minus tan inverse b by a. I have discussed already last class. Tan inverse minus b by a, pi minus tan inverse minus b by a. Since z lies in the second quadrant, pi minus tan inverse 1 by a means minus root 3. Pi minus tan inverse 1 by root 3, there is negative, so it is negative. Since it is within the modulus sign, so it is positive. Pi minus 10, 1 by root 3 means 10, 30 degree, 30 degree is pi by 3, therefore tan inverse 10 pi by 3, therefore pi minus pi by 6, that is 6 pi minus pi, 5 pi by 6, and it is in between minus pi and pi. Minus pi, so it is also the argument, principal argument, and also as well as the argument. We can write this in this sense. Therefore, modulus of z is equal to 2, and ERG, argument of z is equal to 5 pi by 6. This is all about the problem number 2. Now, polar form. What is the polar form of a complex number? That is polar form of complex number. It is polar form of complex number. Let z is equal to a plus I be a complex number. Now if a greater than 0, b greater than 0, then we can plot this complex number as in figure. In the first quadrant we can plot this, since we consider a is greater than 0 and b is greater than 0. Here is the point PAB corresponding to the complex number a plus ib. Therefore it is b, it is a, it is b, and it is r, it is theta, it is the argument of the complex number. R is the modulus of the complex number. In the right triangle OPM, OPM is the right triangle. Here we can write sin theta is equal to, we know it is perpendicular by hypotenuse. Therefore here perpendicular is PM, hypotenuse is OP. Therefore PM by OP. From here PM is equal to OP sin theta. PM, here is PMB. Therefore B, OP, R, we take is R sin theta. Therefore B is equal to R sin theta. We can write here B is equal to R sin theta. Now what is A? Again cos theta is equal to OM by OP. Cos theta is equal to OM by OP. OM is equal to OP cos theta. OM means this is A R cos theta. Now if we put the value of A and B in the complex number z is equal to a plus ib, then z is equal to a means r cos theta and b is r sin theta. Here get a is equal to r cos theta we have got, and b is equal to r sin theta. We simply put the value in the z is equal to a plus ib. Just taking r common we get this, and this is the polar form of the complex number. This is the polar form of the complex number, where is the r is equal to, r means modulus of the complex number, a square plus b square root over modulus of z, and theta is the argument of the complex number, ARZ. This is the polar form. Now some problem related to the polar form. This is it is also question number 5.2. This is represent the following complex number. Represent the following complex number in the polar form, that is 1 minus I. Let z is equal to 1 minus I. Here also at first we shall find out argument, modulus and argument. Here a is equal to 1, b is equal to minus 1. Now z, modulus of z, we can in polar form we write it as r. A square plus b square, this is root 2, this is. Now argument of z. What is the argument of z? It is in the, yeah, A is positive, B is negative, so it is in the fourth quadrant. Therefore, in the fourth quadrant, ARGZ is equal to, in the fourth quadrant, ARGZ is equal to 2 pi minus tan inverse B by A, or minus tan inverse B by A. That is 2 pi minus tan inverse B means minus 1, A means 1, that is minus 1, 1, twice pi minus tan inverse 1, minus tan inverse 1, this is. Twice pi minus tan inverse 1. 1 is the, what is the value of 1? It is 10 pi by 4. 10 pi by 4 is equal to 1. Therefore, in place of 1, we write 10 pi by 4. Here 10 inverse 10 cancel. It is minus pi by 4. Here also, in place of 1, 10 pi by 4. This is my. But it is 8. 4 to the 8 pi minus pi. This is 7 pi by 4. It is minus pi by 4. But 7 pi by 4 not belongs to minus pi by 4. So it is not the principal argument here. But this is minus pi by 4. This is belongs to minus pi plus pi. Therefore, in case of polar form also, we write the principal argument here only. So polar form of the given complex number is z is equal to r cos theta sin theta. R means here root 2, and theta is not this, but this is. We write only principal argument here. Therefore, cos minus pi by 4, I sin minus pi by 4. This is the problem about next is also exercise number 5.2. Represent the following complex number in polar form. That is question number 5. This is minus 1 minus I. Let's z is equal to minus 1 minus I. Here A is minus 1 and B is also minus 1. Modulus of z, r is equal to a square plus b square. Minus 1 square minus 1 square, 1 plus 1 root 2. This is the modulus of a, or value of r. What is the argument of z? That is theta, or theta is equal to argument of z is equal to minus pi plus tan inverse b by a, or pi plus tan inverse b by a. Since z lies in the third quadrant, minus pi plus tan inverse b means minus 1, minus b means minus 1, pi plus tan is minus 1 minus 1. This is 1. It is also 1. Minus pi plus tan inverse. What is the 1? It is the value of 10 pi by 4. Therefore, 10 pi by 4 is equal to 1. That is 10 pi by 4. 10 pi by 4. Here 10 inverse 10 cancel. Here pi by 4. 10 inverse 10 cancel. Here pi by 4. Therefore, it is 4 pi minus 4 pi plus pi. This is 4. It is 4 pi plus pi. It is minus 4 pi. It is 3 pi by 4. And it is also 5 by 4. But minus 3 by 4 is belongs to minus pi plus pi. 5 pi by 4. It is not belongs to this. Is it is above 180 degree. Therefore, we take this as the argument. For the polar form, it is the z, it is r cos theta is it. R means modulus of the complex number root 2, and theta is the argument. That is we take this is minus 3 by 4, I sin minus 3 by 4. Or this is about the problem in the exercise number 5.2. Next class, we also discuss some problem about modulus and polar form of complex number, and other problem also.